Welcome. It'd be great to hear from everyone. Where is everyone coming from? I know that it's either a good morning, good afternoon, or good evening, depending on where you're joining us from. So hello and welcome to you.
And this is the amazing thing about ICM, International College of Manitoba, and all of us taking part in this, that we all come from different parts of the world. Students and faculty are from everywhere and are everywhere, which is always fascinates me.
I agree. It's always such a pleasure to get to know people from so many different countries. Yeah, feel free to come on camera and pop in the chat where you've come from. We'd love to see where you're from. We're going to get started right away. Welcome to our Spotlight series. All right, well, let's get going here. I'm very happy and excited to introduce our speaker today, instructor from ICM, Dr. David Kattenburg. Dr. David Kattenburg received his degrees in biology and health sciences at McMaster University and has been teaching life science and chemistry courses for a variety of Manitoba colleges and universities since the mid-1990s. Some of you may remember and some of you may not be familiar with the 1990s. Dr. Dave, as his students call him, and it's my honor to also be in that camp of I'm getting to call him Dr. Dave, is also a journalist and radio broadcaster. In the course of his travels, he has visited the Marshall Islands, Southeast Asia, India, the Middle East, Africa, and Latin America. I'm very excited to speak to you today on the topic of microbes. I hope everyone's excited about this. Welcome, Dr. David, and it's your turn to wow us with your information today.
Well, hello, everybody. This is just a pleasure to be taking part in this recorded webinar series aimed at folks like yourselves, you know, young women and men who are planning on coming to Canada to study with ICM, or perhaps you are already here in Canada. As it happens, I'm in the Netherlands, of all places, and pleased to be with you at this moment. Thank you so much, Jenny, for introducing me. There's a certain message embedded in the biography that Jenny shared with you, a certain message or lesson, or there's a moral to the story, which I just want to point out, and that's that you can pave your own road. You can do what you want to do. You can be who you want to be, and you shouldn't, at your age for sure, be overly stressed by where you're going to go and what you're going to do and how you're going to make your living and what you're going to study and, you know, how you're going to support yourself and so on and so forth. Because look at me. I was born in the United States, in the New York City area on Long Island, of European parents. And when I was 18, I went to Canada to go to university. And I ended up studying biology for 4 years. I was always interested in biology. I had a microscope from since a very young age. I'll talk about that in a bit. So I studied biology as an undergraduate at McMaster University in Hamilton, Ontario, without any big ideas about what I was planning to do with it. And as an undergraduate, I got into theater. I became really interested in and became involved in theater, stage theater, university and community theater. So I got my undergraduate degree in 1975, it was a long time ago. And then I spent a year living in Germany, working in a pharmaceutical lab in a big chemical company in Frankfurt, Germany from 1975 to 76. And then I came back to McMaster University in 76 and entered a master's program, but then segued into a PhD, which you could do back then. And it took me 5 years. I got my PhD in health sciences, focusing on the pharmacology and the physiology, the biochemical pharmacology of smooth muscle, involuntary muscle. It's the kinds of muscle tissue that makes it's in the walls of your hollow organs, like your stomach and your intestinal tract and your arteries and the uterus of women, and so on and so forth, smooth muscle. So I spent 5 years doing that. And as I was doing that, I continued with my stage theater, doing theater, university and community theater. And then I got really involved during my PhD years in radio, university community radio as a broadcaster. And by the way, I'm still doing that. I'm still doing radio broadcasting work. But I got my PhD, amazingly enough, in 1981. And then, but I decided at that point that I was not going to continue in science because it didn't interest me to work in a lab. So, but I could, with a PhD, spend 3 years doing postdoctoral research, which I did in Strasbourg, France, from 81 till 84, continuing with work on smooth muscle and living in France and drinking a lot of cheese and eating a lot of wine and having fun. But I did my postdoctoral research, and then I came back to Canada and dropped out of science. And I spent the next several years doing theater, believe it or not, stage theater and a dinner theater in Hamilton, Ontario, and also doing journalism on US-Canada military relations, of all things. There's nothing to do with biology. Well, to make a long story short, in 1994, I moved to Manitoba, the province of Manitoba. And in the mid-1990s, I had my PhD. I started to teach university courses in the life sciences. And over the course of the next 20 years, I would teach a whole bunch of different life science courses, biology, microbiology, various types of microbiology courses, anatomy and physiology, pharmacology, chemistry, inorganic and organic and biological chemistry. And I could do all these things because I had my PhD. So in brief, I'm a guy who teaches university level life science courses and have been doing it since the mid 1990s with my PhD. I'm Dr. Dave, but I'm also a journalist. I'm also a writer and a radio journalist and a radio broadcaster and a web publisher. And you can go check out my webpage, greenplanetmonitor.net, www. I'm going to write it over here. This is my webpage, www.greenplanetmonitor.net. It's very eclectic. It's a webpage I need to look after. It's a web magazine. But okay, what's the message here? The message is you pave your own road, you build your own path, you chart your own course, you decide your own future. You're not necessarily committed to doing anything down the road just because you've chosen a certain path. So as you explore university with ICM in Canada, don't be too stressed about what your ultimate objectives are or should be. Enjoy the courses you're taking, learn as much as you can, and be as successful as you can, and have fun, be healthy, be happy, be interested in what you're studying, and understand that at your age, right, 18, 19, 20, 21 years old, you really have no idea where you're going to end up and what you're going to be doing as a professional down the road. That's the first kind of bit of stuff that I want to share with you. Using me as a life example, like, look at me. I've led an interesting life over the course of the years. And now I teach microbiology for International College of Manitoba. So microbiology is an amazing subject. And I've been interested in microbiology for many, many years. When I was a kid, I had a microscope and I used to look at things under the microscope, things like, onion skins and, bits of vegetable matter and soil and water and, various other things, which I don't need to talk about. But I was always fascinated by these things under the microscope, looking at them. And as an adult, I have in my storage locker back in Hamilton, Ontario, I have a kind of an expensive microscope that I'm going to have to go back and bring back to Europe so I can play with it. And it's a professional medical microscope. I've always enjoyed looking through my microscope, and the things that you see under the microscope, like microbiology is the study of things that are so small that you can only see them using a microscope. These are by and large single-celled creatures, which are either prokaryotes, meaning they have no true nucleus. They're very small, simple cells with no true nucleus, no internal structure to speak of. These are the bacteria, the true bacteria, and the archaeans, which if you look at an archaean, you think, oh, it looks like a bacterium, but they're different from the true bacteria. But they're also prokaryotes. But you'd look at an archaean, you'd think that's a bacterium. So you've got the single cell creatures are the prokaryotes, like the bacteria and the archaeans. And then you've got the single celled eukaryotes, which do have a true nucleus and they're bigger. And this is what we study in microbiology. I remember looking at this guy here. Actually, I'm going to stop sharing here for a minute, and I'm going to maximize this because that's the only way I can share it. Here I come back. I remember looking under the microscope and pulling out some pond water and viewing this creature, which is called Vorticella. Can you see this guy? Can everybody see this?
Yes, we can.
Good. So a vorticella, it's this large single-celled creature with a true nucleus and internal structure. And it's got a mouth, quote unquote, a mouth, with a set of cilia, which are these little hair-like things that are arranged around its mouth, quote unquote, which rotate, which move in unison and create a kind of a vortex, which is like it's a little cyclone or a tornado, a vortex. It's why it's called Vorticella, which draws things into it. And I was looking at one of these creatures under the microscope once and just thinking, this is amazing. It's got a holdfast over here, which anchors it to the substrate, to the rocks or whatever the surface is below the water. And it just sticks its neck out. Now, I'm going to stop this, right? Because this is what YouTube does. I was watching this thing under the microscope, and suddenly a little sporillum, a little bacterium got sucked in. This is a bacterium. This is a prokaryote, which is very obvious under the microscope because it's big enough to see. And it's also got a shape. It's shaped like a spiral, like kind of like a corkscrew, and it rotates, goes round and around and around. So it's easy to resolve. You can see it, although it's tiny. And this little guy got sucked into the vorticellin and down through the mouthpiece and ended up inside of a vacuole, a little vesicle inside of the vorticellin, which is a digestive vacuole. And I could see it inside the vacuole, and it was still moving around. I had to avert my eyes. I thought, this is awful. This is terrible. This little guy is about to be digested live. I had to shed a tear, I kind of had to blow my nose, and it was kind of sad to kind of see this little guy get, so I had to go away because I didn't want to see it getting digested live. This is amazing. Another time I was looking under the microscope at at a colonial creature. A colonial creature is now a Vorticella is a eukaryote. It's a large cell, very, very visible, much bigger than a bacterium. I was looking at a colonial creature, which consists of lots of little individual cells that are independent. Each of them is like an algal cell, little algae. They capture sunlight and they turn carbon dioxide into sugar doing photosynthesis. And these are colonial creatures because they come together into a kind of a ball. It looks like a ball, and with little cilia that are beating, and you can see it. But there might be 100 cells in there, individual, and they're all individual. They're all identical, essentially, but they're all living colonially. There's no specialization amongst them. So I was looking at this colonial creature under the microscope. It was very large, very green, and very wiggling, and I had the light shining through it. And I'm looking at it, and then all of a sudden, ping, all the individual cells go flying off in all directions, obviously under the influence of the light, right? Holy crow, that's amazing. I said to myself, because one instant it was a very large, very colorful kind of sprinkly ball with lots of little cilia beating, and then suddenly looked like a lot of cells. Suddenly, ching, they all go off in all different directions. It's a hidden world. It's a mysterious world that is just fascinating to observe under the microscope. And that's what folks do, students do, and researchers do, and enthusiasts do in microbiology. They study things under the microscope, and we're surrounded by microorganisms, my friends. There are an astronomical number of microorganisms out there in the world. They're astronomical, meaning there's almost as many of them as there are stars in the sky. We're surrounded by them. There are gazillions of them in our world, and in the world around us, and in our world, like on us and in us. And it's kind of hard to comprehend that we have, you do, I do, everybody does, all of us humans, consist of about 10 trillion cells of our own. That's a lot of cells, 10 trillion cells. You know how many bacteria there are on us and in us? How many do you think? Like, what's the ratio? There's 10 trillion of our own cells. How many bacteria are there on us or in us? The same number, or fewer, or more? Yes, there are more. There's about 10 times more. There are about 10 times more bacteria on us, and especially in us, than there are cells of our own. So you get 10 trillion of our own cells. There's 100 trillion bacteria on us, and especially in us, up our nose and our mouth, clinging to the walls of our upper respiratory tract, in our distal urogenital tracts, clinging to the walls, and especially in our intestinal tract. And so there's more of them than there are us, which is raises an interesting philosophical question. We are eukaryotic creatures. We consist of lots of cells that are nucleated, that are complex and large. They are our own cells. They are eukaryotic cells. We are eukaryotic organisms, but there are more prokaryotic organisms in us than there are cells of our own. And so what makes us eukaryotic? You think we are prokaryotic, but of course we're not. So you may ask, why don't we get sick? Well, sometimes we do. When those microorganisms end up where they don't belong, we get sick. Now, in the environment, it's the same story. There are the total mass, the total weight, the total mass, biological mass of bacteria on and near the surface of the earth is way greater than the total mass of all other life forms on Earth. Like, so all the green stuff that you see on the surface of the planet, all the trees, all the grass, all the bushes, all the animals, all the plants, all the humans, we all weigh a certain mass. All that together in the biosphere is a certain mass. The mass of bacteria on and on the surface of the Earth, and especially deep down, is greater. So it's colossal. It's hard to conceive of the mass of microorganisms that are out there, and that make the world go round. They make the world literally go round and round. And if it weren't for them, there wouldn't be any of us. We'd be toast, as we say in English. We rely on microorganisms for everything. Now, I want to wind up here. I mean, just to show you, I'm going to have to go get out of this. I'm going to close that, and I'm going to come back here and share. I'm going to just flash through a few quick views for you. It's in the news. Microbiology is in the news all the time. And this was in the Guardian just the other day. A global mystery hepatitis outbreak spreads to Asia and Canada. Talk about COVID. This is a curious one. Long COVID, doctors find antibody signature for patients most at risk. People get COVID and don't really get better. Here's an article towards killing cancer with bacteria, using bacteria to treat cancers. And here's a story about using viruses to kill bacteria. Because there are viruses out there that infect just bacteria. So if you've got a bacterial infection, one of the cutting edge areas in medical science is using viral therapy to treat infections by bacteria that have become resistant to drugs. It's kind of amazing. What's that weird stuff in the water? Walking around here in the Netherlands, looking at water on the surface in this wetland near here and seeing all this strange stuff that at first I thought, oh my God, there's been an oil spill. Somebody's polluted the surface water. There's a glossy sheen on the surface of the water. Didn't smell like gasoline. So I came back and I found this. Well, like, what's that weird stuff in the water? I mean, as if it couldn't have been predicted. This stuff was bacterial. These are iron bacteria that grow, below, just not very far below the surface of standing water. Antimicrobial resistance is a huge story in the world today. Bacteria that are resistant to drugs are posing now a health threat that's equal to the threat that COVID and other viral pandemics pose. And it's predicted that in 20 or 25 years, antimicrobial resistant bacteria that are resistant to antibiotics, are going to be infecting and killing more people than COVID does at this moment, and has. So microbiology is in the news all the time, every day. And I tell my students, what better period of our lives and in the period in the history of modern history to be studying microbiology, and particularly epidemiology, was the science of dynamics of infectious diseases and populations, than today with COVID on the loose. And there are all kinds of practical issues that we deal with in our daily lives and have for the last 2 years, like wearing masks or getting vaccines or social distancing, or how does COVID spread? Or, if I get vaccinated 3 times, why do I still get infected? Why is it, and how is it that I got COVID? Actually, I got COVID 6 weeks ago or so. It was a mild case. I got three injections and I still got COVID. Now I got a mild case, and now I've got what's supposedly called super immunity, which means that I'm pretty safe for the time being. But hey, how safe am I? Can I go run around in crowded places? if I do, I should probably anticipate coming down with COVID again. So this is all incredibly relevant in the world today, microbiology. So I'm going to leave it at that. Glad to answer any questions you guys have. I would strongly recommend that you consider studying microbiology. If not with me, then with some other instructor with ICM, because it's it'll stir your interest, and maybe you'll end up getting a microscope and looking at things that are hidden because they're there.
Thank you so much, Dr. David. I think it's so important to understand, the relevance of looking at something under a microscope and learning about the things we can't see with our own eyes and how they actually do affect everyone's life. And again, no more perfect example than the last few years of what everyone's been going through and learning about. And I hope that this has inspired some of you here to think more about microbiology. And okay, we got a good question here.
What do you like?
What do I like most?
What do I like most about microbiology? Well, I mean, I have to say, I mean, the topic fascinates me as a biologist, but I must say, I'm bringing my I got to go back to Canada, grab my microscope and bring it here to the Netherlands, because I like looking at things under the microscope. I can't wait to kind of take a little bit of that surface water and look at it under the microscope. I like looking at things under the microscope.
It's a whole different world when you take a look at something literally under a microscope.
Believe it. You would not believe it. And learning how to use the microscope is a lot of fun, because at first you think, how do I do it? And it's hard to see. But after a while, you learn the art and the science, it's the art of looking at things under the microscope. I enjoy that.
I know it's fascinating to take a look at things moving on their own in a different world there. So yeah, that would be so interesting to see.
The difference between a eukaryote and a prokaryote, well, all living things are made of cells. All living things are composed of cells, which are the simplest structural units of life. The smallest living things are living things that consist of just a single cell. So there's two types of cells out in the world. There are prokaryotic cells. They're small and simple. They've got no true nucleus. Their genetic material just floats naked in their inside. And then we've got eukaryotic cells, which are larger cells, and they're very complex, and they've got a true nucleus. Their genome is inside the nucleus. So we are eukaryotic organisms. We consist of lots of eukaryotic cells, although of course we've got more prokaryotic cells inside us than our own. The simplest eukaryotic cells are like the Vorticella I showed you, just single cell creatures, large cell with a true nucleus. The prokaryotes are the bacteria.
Any other questions before we wrap it up for today? Well, thank you again. Oh, one last one here. How does the vaccine for any disease protect us?
By stimulating our immune system, by poking our immune system. And vaccines consist of typically of microorganisms or parts of like microorganisms that have been crippled, attenuated. So they stimulate us, but they can't really make us sick. And parts of microorganisms, which, just a little fragment, which is what the COVID vaccine is, just a little fragment of the virus. And they stimulate our immune system responds, mounts a response, and then remembers this microorganism or the little bit. And then if we ever see it again, we're now immune, quote unquote, we resist it. So that's what vaccines do. They stimulate our immune system. They teach our immune system to respond to infection by microorganism if we ever end up seeing it again.
Helping our bodies help themselves, definitely. Well, thank you again so much, Dr. David. This has been enlightening and wonderful. We appreciate your time and sharing your wisdom with us. Dr. David, of course, is someone that you can meet at ICM once you start taking some classes if microbiology and some of his interest you. I know he'd be happy to talk about many of the different lives and interests that he has as well, of course, with any of you. If you are interested in our next spotlight series. We do have one next week with Dr. Sean McFarlane on Tuesday, May 10th. We're going to dive into chemical world, chemical knowledge. So if you're interested in vaccines, new medicines, and how these things work, this is a topic that may be discussed next week on Tuesday as well. What would happen tomorrow if chemists were to disappear? Well, basically human prosperity would end, apparently. So we'll find out more from Dr. Sean McFarlane next week on Tuesday. So thank you again, Dr. David. Thank you everyone for coming out today. We'll see you next time, and have a great day. Have a good evening. Have a great rest of your week. See you later.